Good evening, guys. I hope you're all well. I've got a question for you here, which is like physical science, Newton's laws, from the exam paper. So we have a question 2 here, which like we're gonna read our statement here. So the statement says two blocks, A of mass 4 kilograms and B of mass 9 kilograms, are connected by a light and extensively string. The blocks are held at rest on a plane which is inclined at an angle of 35 degrees with the horizontal. A constant force F acting parallel to the plane is applied to block B as shown in the diagram below. The blocks now accelerate up the plane at 2 meters per second squared. So now we have our diagram there. We can see like we have two blocks there, which is like 4 kilogram and 9 kilogram, connected by a string, right? So they are pulled by force F on an inclined slope that is 35 degrees. So the first question, which is like 2.1, says state Newton's second law of motion in words. Which like Newton's second law of motion in words says that when an object accelerates in the direction of the net force, acceleration is directly proportional to the net force and inversely proportional to the mass of the object. And then now we have a small statement there which says the kinetic frictional forces acting on blocks A and B are 5,88 newtons and 13.23 newtons respectively. And then 2.2 says draw a labeled free body diagram showing all the forces acting on block A. So since now we'll be drawing a free body diagram for block A, we check our block there which is on an inclined slope. So we're gonna check our normal force and check our force of gravity. So now we're gonna draw a small dash here indicating the block. So we have a force acting perpendicular to the slope, which is oblique, which is our normal force. And then we have a force of gravity, which is pulling the object to the ground, which will be parallel to the y-axis, which is force of gravity. And then we have a tensional force acting up the inclined slope, which is force tension. And then we have force of gravity, which is acting opposite to the tensional force, frictional force. And what else do we have? Which like we've got 4 marks there, meaning that each mark is for each force, right? And then we move to 2.3.1, which says calculate the magnitude of the tension in the string, right? So in this case we'll be focusing on both the blocks of like 4 kilogram and 9 kilogram, but firstly we'll work on block A. Since it's Newton's second law, we're gonna apply Newton's second law of motion, right, into question 2.31. So we're gonna write F net it's equals to MA, right? And then we're gonna write our forces, right? We have tensional force acting up the inclined slope, right, plus minus frictional force which is acting down the slope because it obstruct the block from moving upwards. And then we have parallel force of gravity, which will like draw the object downwards, because like force of gravity in this case it's working parallel to the slope, right? So it's gonna pull the object downwards. It's equal to MA. So now we have included all our forces acting on block A, which is like tensional force acting upwards, frictional force acting downwards, and also gravitational force which is parallel to the slope acting downwards. And then now we're gonna insert our values, which like for tensional force we are calculating for it, meaning that it's unknown. And then we are given frictional force for block A, which is 5.88. And then now do we have force of gravity which is parallel to the slope? Okay, let's check. We don't have force of gravity which is parallel to the slope, but we do have the mass and the angle, right? Meaning that we're gonna say that which for force of gravity parallel to the incline, it's mg sine of theta. It's equal to, we've got the mass for block A, which is like 4 kilograms, and we got the acceleration, which is like 2 meters per second squared. And then now, since we don't have the tensional force, we have the frictional force, which is 5.88. We substitute the mass of block A, which is like 4 kilograms, and the gravitational constant, which is 9.8, and then sine 35 degrees is equals to 8, and then you do your mathematics there to find tensional force. 8 plus 4 into 9.8 sine 35 degrees plus 5.88. It's equal to tensional force, it's equal to 36.36 newtons. And then we move to the following question, which says calculate the force F. So now, since we have found the tensional force, now we have to work on block B to find force F, right? Because it's the one that is getting pulled by force F. So now what we're gonna do, we're gonna write our free body diagram so that we can make it easier so that we can calculate for force F, right? So in this case, we have force F going upwards the incline, and then we have normal force, which is perpendicular to the incline, force, normal force, and then force of gravity, which is going downwards. And also we have tensional force on the same side as the frictional force, right? We have Fk, we have tensional force, right? And then tensional force on the acting on the block A is the same as tensional force acting on block B, but they're acting on opposite directions, so that's why this one will be negative and then the other one will be positive. So now we indicate to the examiner that we'll be working on block B. Then you use your formula for Newton's second law, which is F net is equals to ma. So now you're just gonna write your forces into the formula, which is the force we are looking for plus minus Fk plus minus tensional force plus minus force of gravity acting parallel to the slope, which is moving downwards. It's equals to ma, and then we substitute our values. We don't have the force, the applied force acting on block B, so we are looking for it. We have the kinetic friction, which is 13.23, minus we have the tensional force. We calculated it on the previous question, which is 36.36, minus we can look for force of gravity acting parallel to the slope, right, which is mg sine theta. It's equals to, we have the mass, which is 9, we have acceleration, which is 2, and then force, it equals to 13.36 minus 13.23 minus 36.36, it's equal to 23.13, and then we substitute the force of gravity, which the mass is 9, and gravitational constant, which is 9.8, sine 35 degrees, it's equal to 18, right? 9 times 2, it's 18, and then you do your maths to find the force acting on the block, which is 18 plus 23.13 plus 9 into 9.8 multiplied by sine 35 degrees, which gives you 18 plus 23.13 plus 9 multiplied by 9.8 multiplied by sine 35, which gives you 91 91.72 newtons. Now the force acting on block B is 91.72 newtons. And then we move to the last question, which is 2.41, which says the angle that the plane makes with the horizontal is now decreased. If the angle is now decreased, the following question says, how will this change the kinetic frictional force acting on block A? Choose from increases, decreases, or remains the same. So in this case, if like the angle of the plane is decreased, then the kinetic frictional force will increase in this case, because now the slope like is decreasing, meaning that the kinetic friction will pull the blocks downwards more if like the slope is decreased. So the kinetic frictional force will increase in this case. 2.4.2 says explain the answer to question 2.41. So in this case, how will you explain it? Meaning that you're gonna say, as the kinetic friction decreases. So in this case, if the angle of the slope decreases, kinetic friction will increase, due to kinetic friction being directly proportional to the normal force. That's the reasoning for the last question. Thank you for your time. Hope you have a wonderful day. Please don't forget to like and follow.